Hello, in this video I am going to solve a problem for you on the topic of trigonometry. I cannot categorize this problem under a specific category, so I will call it a miscellaneous problem. Okay, so let us read the problem together first. Let phi be a trigonometric angle in the fourth quadrant. The expression square root of 1 plus 2 times the square root of sine phi squared times 1 minus sine phi squared is equal to, you have four options available here. Part 1, A, sine phi plus cosine phi. Part B, sine phi minus cosine phi. Part C is minus sine phi plus cosine phi. And finally, D is minus sine phi minus cosine phi. Only one of these options are correct answer to this problem. That would be a good idea if you pause the problem, pause the video at this point and try to solve the problem yourself first. If you do the problem correctly and understand what is the point of this problem, you will get the answer, the correct answer to be option C, which is minus sine phi plus cosine phi. Okay, now let us go to the board and solve this problem together. So this expression, I am supposed to simplify it as much as possible under this condition that phi is in the fourth quadrant. So if you check the options available here on this slide on top, you will see that in none of them I have the third sign. I do not have any track of square root signs left in my options, so this motivates me that the first thing that I have to do probably is to get rid of these square root signs. Okay, but how can I do that? So here, this is a famous combination in trigonometry, yes? So you know that. So let me, if you don't mind, let me call this A, capital A, so that I can refer to this expression simply. So what I do, I would say that sine phi squared plus cosine phi squared, regardless of the value of this angle phi, you know this is a very famous trigonometric equation identity, which is 1. So I want to know a little bit about this combination, so this motivates me that I move this term to the other side. So this one is still left on the left-hand side, and then it becomes 1 minus sine phi squared. So you see that this combination that appears here is nothing except cosine phi squared. So now what I do, I will say that, okay, the expression A is equal to square root of 1 plus 2 square root of, then I would write sine phi squared, but instead of 1 minus sine phi squared, I can write cosine phi squared. But then I have two complete squares multiplied, so according to the power rules, I can write one single power of 2 and then multiply the bases. So this becomes sine phi cosine phi. And now here, that is the point that you have to be very careful, because you see, if you have seen the options, they only differ by a minus sign or a plus sign, so there is no big difference between them. So you have to be careful about this one. So one common mistake among students is that if I ask them what is the square root of x squared, they immediately answer that is x. But there are some truth to this, but that's not the whole story. So mathematically, this is a wrong statement. It's a false statement, because there are some counterexamples. For example, if I ask you what is the square root of minus 2 to the power of 2? On the one hand, you know the answer even without a formula, because minus 2 to power 2 becomes positive 4, and the square root of positive 4 is 2 based on your previous knowledge. But if you want to use this formula naively, this minus 2 is playing the role of this x, and this 2 is the same 2. So you might say it is also minus 2, but this is nonsense. 2 cannot be equal to minus 2. So what the problem is that this formula is not the whole story. It's not correct. It's only correct if x is positive. So what is the general formula? The general formula is that square root of x squared is absolute value of x. So if I use the correct version of that, I am not allowed to write -2. I have to write absolute value of -2, and the problem is solved because absolute value of -2 is again 2, and I do not have any contradictions whatsoever. Yes? And if I ask you what is absolute value, so let me just write it here. So what is absolute value? How absolute value of x defined? Absolute value of x, I cannot remove the sign of absolute value unless I am sure about the sign of the expression inside the absolute value. If I am sure that this expression is positive, I can simply remove that. So if x, which is inside the absolute value, is non-negative, I can safely remove this absolute value sign without any changes. But if I am certain that that expression is negative, still I can remove the absolute value sign, but I have to apply a minus sign overall to the expression. So absolute value of x is not always equal to x. It is equal to x if x is non-negative. It's equal to the negative of x if x is negative. But in any case, the output of an absolute value is positive, because if x is positive, of course x is positive. If x is negative, minus x is still positive. Okay. So, if I want to continue this, I would say this becomes square root of 1 plus 2. Instead, this will play the role of my x in that formula. This is power 2, so the answer, it is just absolute value of sine phi cosine phi. Okay, so far we got this. But can I remove the absolute value sign? The answer is yes, because I have an extra piece of information provided for me. So here, phi is in the fourth quadrant. If I am in the fourth quadrant, I know cosine is positive and sine is negative. So then it means that the product is definitely negative, because one of them is positive, the other one is negative, so the product is definitely negative. And if this is negative, can I say something about the absolute value of sine, cosine, phi? The answer is yes, because now I am certain about that this expression is negative. According to the definition of absolute value sign, I can actually remove that. Then the price that I have to pay, of course, is to put a minus sign there. That was extremely important. If you do not follow this, you just write, if you naively just write sine phi cosine phi, then you will have a positive sign here, but you know that the correct answer is the same expression but with a negative sign. So if I come back and then try to solve that problem here, so if you don't mind, let me take this slide so it's not making problems for you. Okay, so here this becomes a square root of 1 minus 2 sine phi cosine phi. So far it is successful. Yes? Because at least I got rid of one of these surd signs. But I'll have to get rid of the next one as well. But how can I get rid of that? Apparently I do not have any powers of 2 left. But the point is that you need to remind yourself about this, the same important identity, yes? So instead of this one, I write sine phi squared plus cosine phi squared. This is one of the few cases that I make a simpler expression more complicated, because usually mathematics we are used to make complicated expressions simpler, but there is a reason for that, because if I do that, so I would write it the square root of, instead of 1 I write sine phi squared. If you don't mind, let me write cosine phi squared here, because sine phi squared plus cosine phi squared is exactly 1. I intentionally write that because I want to make it easier for you to detect a pattern. And hopefully now everyone understand what the pattern is going on, this is the complete square. Yes, so what I can do, I can write the square root of sine phi minus cosine phi to the power of 2. Why is that correct? Because if I ask you to expand this, you would say the first one squared, you will get the first term. 2 times the first one times the second one, you get the second term. And then the second one squared, you get the third term. That's completely correct. But if I ask you what the answer to this is, I hope that, so if you don't mind, let me draw a line here. I hope that you don't answer this. Because if you answer this, this is option B if I am right. So this is not option C, I'm sure about that. So you might get the wrong answer once more. So you're just losing that chance again. So be careful about that. This is not correct. Because the good point about mathematics is that for the formulas that you prove once for all, there are no exceptions. So square root of x squared is not x, is absolute value of x. So if you give the role of x now to this expression, this is a square root of x squared again. It is not equal to x as I have written here. I have to respect and put absolute value sign here. But of course, this is completely correct, but this is not an option in one of my choices, in one of my options, so I have to go further. I want to get rid of the absolute value sign, but there is only one way to get rid of it, to make sure what is inside is either positive always, certainly positive, or certainly negative. Which one is the case here? Look back here. Cosine phi is positive, sine phi is negative. So what happens? Sine phi is a negative number. Cosine phi is a positive number. But I have a minus sign here, minus positive, so again it becomes negative. So this part negative, that part negative, I am adding two negative numbers, so the answer becomes negative. So then, hopefully you understand that I was able to convince myself the expression inside the absolute value sign is always negative. So then, am I allowed to remove the absolute value sign? Yes, but I have to pay something as the price. And the price is to multiply the expression by a negative sign. Okay, now if I multiply this minus sign in, so this becomes minus sine phi, the other one becomes plus cosine phi. And then hopefully you see this is option C in the set of questions. So this is a tricky question, and this is designed to teach you to respect to this formula. Because if you do not respect that, then you will make mistakes. And all four possibilities have been actually used in the options. So if you make one part wrong, then you will choose the wrong answer. Okay? I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.